Hi, we are going to be looking at balanced equations and look at how we can use mole-to-mole ratios to predict how much product can form or how much reactants need to react with one another. This is called stoichiometry. And you've heard me say the word before, but I don't know that we've really clearly defined it. Now we're looking at the quantitative study of reactants and products in a chemical reaction. Up to this point, we've been predicting what the products would be, but we've never really talked about how much product you would make or how much reactant needed to react to make a certain amount of product. And so that's what we call stoichiometry. We're looking at the quantitative study of these balanced equations. And so I thought we would start with an easy equation. 2H2 plus O2 gives us 2 waters. Now, we spent a lot of time learning how to balance equations, and we're putting in these coefficients out front. And when there's not a coefficient, it's understood to be a 1. But you know, we really haven't done anything with them since we balanced the equations. Well, now it's time to really look at what they mean. Now, it takes twice the amount of hydrogen in moles to react with oxygen. So in other words, if we had 2 moles of hydrogen, 1 mole of oxygen would react with it to form 2 moles of water. So it's a mole-to-mole ratio, and we can see here we need twice as much, or 2 to 1 moles of hydrogen to oxygen in this reaction. All right, so let's ask some questions. All right, if 2 moles of hydrogen reacted, how many moles of oxygen must react? Well, half as much. So 2 moles of hydrogen would be 1 mole of oxygen, and that would form 2 moles of water. Okay, I like to think of this kind of like a recipe. So it's kind of like you need 2 eggs and 1 cup of milk or something. So you need twice as many of this as you need of this. Okay, so if that helps, think of it like a recipe. Now, what if we had 4 moles of hydrogen react? So in other words, double the amount in our balanced equation. So not 2 moles, but 4 moles of hydrogen. How many moles of oxygen would need to react with that? Well, it's a 2 to 1 ratio, and so it would be 2 moles of oxygen. And look how that coefficient 2 is the same here with water. And so if we change this to 4 moles of hydrogen, we would be making 4 moles of water. What if only 1 mole of hydrogen reacted? Okay, if 1 mole of hydrogen reacted, how many moles of oxygen would react? It would be a half of a mole to form a mole of water. The thing is the numbers aren't always so nice to us, like 0.425 moles of hydrogen. So you can think of it like a recipe, and so it'll make sense to you, but we have a method to help you keep these numbers straight. So I'm going to go right in here, and I'm going to start with 0.425 moles of hydrogen. Write your number, write your unit, and identify moles of what? Okay, moles of hydrogen. All right, and now this is our mole-to-mole ratio step here. We know that we have 1 mole of oxygen that needs to react for every 2 moles of hydrogen that reacts. Notice the hydrogen was in the numerator, so it goes in the denominator. And then what we want goes on top. Now, where did that 1/2 come from? That's the coefficient in our balanced equation. 1 oxygen for 2 moles of hydrogen. And so what we're doing here is we're actually dividing 0.425 divided by 2, which will give us 0.213 moles of oxygen. We really need to practice this. All right, so here we go. This is another really common equation. 1 mole of nitrogen reacts with 3 moles of hydrogen to yield 2 moles of ammonia. NH3 is ammonia. All right, now, if 2 moles of nitrogen react, how many moles of hydrogen react? Well, it's not quite as easy. You know, it's a 3 to 1 ratio, but let's just go ahead. Always start with what's given. 2 moles of nitrogen. And now we're going to do our mole-to-mole ratio. Put on the top what they're asking for, moles of hydrogen. And then, what did we have? We had moles of nitrogen. All right, so that they will cancel. So moles of nitrogen cancels. What we want is on top, or what they're asking for, is moles of hydrogen. All right, so 2 moles of nitrogen. Now this mole to mole ratio, come up here, get the coefficient for hydrogen. The 3 goes with hydrogen, and the 1 goes with nitrogen. And so the answer is 6 moles of hydrogen would have to react if 2 moles of nitrogen reacted. That makes sense. We need 3 times as much hydrogen. Now they want to know how many moles of ammonia form. Well, we have 2 moles of nitrogen. That was what was given. And now the question is moles of ammonia. That's what we want. And H3 is ammonia. And so we got to get rid of moles of nitrogen. This is our mole to mole ratio. Go to your balanced equation. 2 goes with the ammonia and 1 goes with the nitrogen. And so we see that we would get 4 moles of ammonia that would form. Okay, so it's really important right now that you use your unit mole and you identify, like it's moles of nitrogen. Make sure you do that because that's really going to help you. All right, let's do another problem. Same equation, but different numbers. All right, here we've got 0.314 moles of hydrogen that react. And they would like to know how many moles of nitrogen would react with that. Okay, so down here, we're going to put moles of hydrogen so that they will cancel. And then we're going to put in the numerator what we want. And they're asking us in the first question for how many moles of nitrogen. So this is our mole to mole ratio. And 1 mole of nitrogen for 3 moles of hydrogen. So it would be 0.314 divided by 3. And that would give you your answer. So that would give you moles of nitrogen. All right, what about moles of ammonia that form? Again, same thing. You've got moles of hydrogen given. What do you want? You want moles of ammonia, and you had moles of hydrogen. Our coefficient 2 to the coefficient of hydrogen, which is 3. So it would be 0.314 times 2 divided by 3. And that answer, so go ahead and do it on your calculator, would give you moles of ammonia. Okay, so why not just one more just to practice? All right, 0.764 moles of nitrogen react. And they would like to know how many moles of hydrogen react with it. Well, in the denominator, moles of nitrogen so that it will cancel. And we're going to put moles of hydrogen up here. It's a 3 to 1. The 3 goes with hydrogen and the 1 goes with the nitrogen. So 0.764 times 3 will give you how many moles of hydrogen. So go ahead and do that on your calculator. And then they want to know how many moles of ammonia form. All right, so here we go. 0.764 moles of nitrogen. We want moles of ammonia, so that goes on the top. And moles of what was given, the nitrogen goes on the bottom. And this mole to mole ratio is our coefficients in the balanced equation. And so ammonia has a coefficient of 2, and nitrogen has a coefficient of 1. 0.764 times 2 will give us our answer. So do that on your calculator if you need to, and you will get moles of ammonia. Okay, so mole to mole ratio. We're using the coefficients from our balanced equation to determine the ratio of reactants that react with one another and the products that are formed. So we're going to practice this in class, and then we're going to add to this. Have a good evening.